Hello, everybody. I'm Nathan, your professor for this course. Due to the fact that there are 13 presentations and only 12 students, it's my pleasure to share this week's presentation with you. I'm excited to share about the neurobiology of addiction. Couple of reasons why this is important. One, because addiction is a neurological and biological issue. It is something that exists in the brain. We call it a brain disease. That's important because we want to look at this from a science-backed perspective, not from necessarily a moral or choice perspective, like a lot of people do look at addiction and substance use disorders. Understanding that it does start from a moral and choice place, but it ends up becoming a brain disease. So we're going to talk about that a little bit. I want to talk about how addiction affects the brain, which is the neurology piece. And the brain is also part of our biology. It's a part of our body, and that's the biology piece. Okay. Just throw out real quick that I am not a neurologist. I consider myself an amateur neurologist, similar to how you might see an amateur astronomer or somebody who just kind of plays around with stuff. But I do find that the study of neurology very much supports my work in clinical practice working with people. So getting into this presentation, if you take a look at the slides, we want to look at some basic brain structure. You can pause at this moment and take a look at Dan Siegel's video if you haven't already. You don't have to watch the whole thing, but he introduces this concept of the handy model of the brain. Okay, so he puts his thumb in the middle, wraps his fingers over the top, and I use this with my clients all the time. What we have is imagine this is your brainstem and your spinal column. The thumb in the middle is the amygdala and hippocampus and the midbrain. This is the seat of emotions. And then up on top is our cognitive thinking brain. What's important to start with is this understanding that everything about our brain biology is based on survival. Okay, so all that we know about brain neurology, my starting point for all of that is that everything is the result of our need for basic survival. This brain is built this way to help us survive. Let's look at a normal event that may happen is you imagine you're walking down a trail and a bear jumps out in front of you. Okay, you immediately experience, you receive the sensations into your body. You receive, you see it, you hear it, you feel it. Those sensations come in and they'll hit this midbrain first. That's the seat of emotions, and we experience what? We experience fear. Now that fear, if it's strong enough, will skip this part of the brain. It won't send anything up to thinking about how fast can bears run, how fast can I run, and we sit down and have a good long conversation with ourselves about what we know about bears. Instead, it'll send an automatic reaction back down into the body. Dan Siegel talks about this as an automatic response or something that happens right away, and it's built that way to protect us. What happens is with addiction, this is where addiction lives, is in this midbrain. So addiction is an emotional experience. It's something that releases feelings of pleasure, of excitement. The same is true for trauma. That fear is so strong that it circumvents our ability to slow down and think through things. That's why I like this model of the brain. Also helps us to understand the upstairs, downstairs, left and right, as we'll see a little bit later. That upstairs part gets shut down over long-term use of this downstairs part. We know about neuroplasticity and the fact that the brain adjusts and over the course of time continues to strengthen in areas that we use it a lot and weaken in areas that we don't use it. And so if we're using this all of the time, that gets red hot, and that will last, and it will direct a lot of our decisions without us thinking through them. That's what kind of addiction is. All right. So that feeling of pleasure that occurs here in the midbrain, that's the result of a neurotransmitter or neurochemical. Our activity of the brain is chemical and electrical. And these chemicals, the chemical that is associated with addiction is, if you've done your reading and other assignments, is dopamine. Where we get the idea of dope, right? Drugs, we call them dope. So that dopamine, what's important to know about that is that normal response of two neurons talking to each other, and you have a sending neuron and a receiving neuron. If you look at the picture on the presentation, you can see that the sending neuron will send out a chemical and it'll float in that synaptic space, and the receiving neuron will receive it, will absorb it. So it sends out a dopamine, it sits in that space, and then the receiving neuron receives it. So you eat a piece of chocolate cake, boom, sends a dopamine, receives the dopamine. You feel pleasure for a little while until all the dopamine is soaked up, and then you move on with your life. This is obviously a gross oversimplification. What happens when you inject heroin into your vein is now you flood about 10 times the amount of that dopamine into that synaptic space, and this neuron is satisfied for a long, long time. He just sits there and soaks up all that dopamine. But again, the brain is plastic and it's always seeking homeostasis, and so what happens is now you start to add more neurons that can flood dopamine to try to balance that. But then, so you're just flooding more and more dopamine. But the problem is that you're also adding more neurons that are soaking up that dopamine. And so now you have less and less satisfaction because these slurp up all the dopamine way faster. That's where we get to the concepts of tolerance and dependence. Okay, tolerance is that you can handle more and more and more. And dependence is the idea that you need those chemicals to be able to maintain basic body functions. Tolerance is that you need more of the chemical to get the same feeling, or that the same amount of the chemical doesn't provide the same feeling. So that heroin, if you keep taking the same dose, it doesn't give you the same feeling anymore. Or if you take or you need to take more and more to maintain the same feeling that you used to get, because we've grown more and more of those transmitters, more of those neurons. What they do is they get closer together and stronger, and then that's where a lot of that addiction occurs. What's good to know about that also is that when we stop the chemical use, now all of those receptors are still there and they're still thirsty for dopamine. That's where withdrawal symptoms come from. That's where that frustration and desire for more drugs comes from. Over the course of time, though, we know that our brain will start to get farther, those receptors will get farther apart, and they'll get back to normal. Maybe not completely normal. Some of this stuff is a lifelong change, but it'll eventually get back to a place of normal, healthy living. The last slide, and I know I'm over my time just a little bit, but the last slide is about the way that the brain changes over the course of time. Remember I said that handy model of the brain? What we see in some of these is that this part down here, this midbrain, gets red hot. And in late stage addiction, this part up here, the thinking part of the brain, doesn't really work so well anymore. It slows down in its ability to make decisions. Even the frontal cortex, where we make decisions about whether something is morally right or wrong, that pathway gets interrupted, and so now we're only thinking with our feelings. I want more of that pleasure, and I'm going to go get it at whatever cost. That's what ends up happening with people in late stage addiction. You see that in that brain scan, there's a healthy brain on the left, and on the right we see an addicted brain, which has significantly reduced brain activity and also concentrated in that amygdala hippocampus back of the brain there. Okay, I hope that was somewhat understandable, not super confusing. I hope that the overall takeaway from this is that the brain adjusts and changes, that the core chemical that is important with addiction is dopamine, and I hope that you get the concept that all of this can be reversed over the course of time, and that healing is possible, but also an understanding of why addiction occurs in the brain and why it's so important that people get professional help to be able to recover from their addictions. Please send me questions. Happy to answer questions on the discussion post below or above, whichever direction you're reading your discussion board. But looking forward to interacting with you on the discussion board there. Thank you.